Hello everyone. So today I want to talk about the concept of source transformation. And essentially, source transformation is a way for converting a voltage source to a current source. And being able to do that in our circuit analysis, or having that as an additional tool, I think will make some problems much easier. So I'm going to very briefly introduce the concept of source transformation, and then we'll dive right into an example so you can see how this can be really, really useful. So the idea behind source transformation is that if you have a voltage source, I'll call it Vs, and it's in series with a resistor, I'll call that R. That circuit is equivalent, mathematically equivalent, to having a current source in parallel with the resistor. And the value of this resistance is the same value of the resistance in the original voltage source here. And then this current source value, so the current here, I, is going to be equal to the source voltage divided by the resistance. And so this is a powerful concept because this works always. Like you can literally in any circuit, if you see a voltage source and a resistor and it's connected somewhere between two nodes in a circuit, you can literally replace it with this and then solve the circuit. And sometimes doing this kind of replacement is makes your problem like much easier. You can also go the other way. If you were solving a circuit and you noticed a current source in parallel with a resistor, you could replace this whole thing with this and then solve your circuit. And I think you will find that in some cases, replacing current sources with voltage sources will make your problem a lot easier. So let's go ahead and do an example so we can see how this works here. So let's say you have the following circuit here. You have a current source, IS, and then you have resistor in parallel here, and then voltage source, another resistor, another voltage source. I'll call this R1, R2, and R3. This will be VS1 and VS2. And let's suppose that we want to find the voltage across this whole circuit. So plus or minus, I'll call it VAB if we called this node A and this node B. And so we want to find what that voltage is. Now we have all the tools already to be able to solve this circuit from previous videos. We could do either mesh analysis or nodal analysis, and we could do it that way, but we'd end up using quite a few equations. And what I want to show in this example is using source transformation, we can actually greatly simplify it. So it turns out that because everything's in parallel here, if we convert these voltage sources into current sources, we can then greatly simplify the circuit and find out what this voltage VAB is going to be. So let's rewrite the circuit and transform these voltage sources into current sources. So we have, let me, I'm going to make this a little smaller. Okay, so we have current source here, IS, and then our resistor R1, and now we're coming to this source here, and so we can convert that into a current source. And a resistor in parallel. And this is going to be R2. And the current here is going to be Vs1 divided by R2. So those two are equivalent. I just converted it into a current source there. And the same thing goes for the other voltage source here. I can convert this into a current source and a resistor. The resistance is the same, it's R3. The current source value is going to be Vs2 divided by R3. So that is this transformation. So now that we've done that, notice now everything's a lot more simple because now everything's a current source and you have all these resistors in parallel, so it makes it very easy to combine everything. So what we can do is, because all these currents are going in the same direction, we can combine all of them into a single current source. So this becomes current source equal to IS plus Vs1 divided by R2 plus Vs2 divided by R3. That whole thing, all of them summed together. And then we can also combine all of these resistors. We have 3 of them. So say this is R equivalent is equal to R1 in parallel with R2, which is in parallel with R3. And of course, that's just equal to this. So you plug all those numbers in. So, and this is our A and our B, right? We're wanting to find VAB. So now the problem is super simple. So VAB is just simply equal to R equivalent times our current, which is IS plus Vs1 over R2 plus Vs2 over R3. And so then you can just plug in chug with your numbers. So you can see how this is just so much more simple and straightforward than if we had tried to do like mesh or nodal analysis. So this, I think, is a really powerful concept and a really cool tool that you can use. And you can even combine it with other techniques. You potentially could convert, for example, voltage or current source in order to make nodal or mesh analysis easier. So just to keep this tool in the back of your mind is really handy for future circuit analysis problems. I hope this was helpful, and I will see you in the next video. Hello everybody, thanks for watching. If you found this content helpful, would you please consider liking and subscribing to the channel? That will help other people find it. And if you won't do it for me, will you do it for my cat, Muon? Named after my favorite subatomic particle, by the way. So, she will be very, very upset if you do not like and subscribe. So please, don't disappoint. How could you say no to this cuteness?